That's the recording started, and I will stop this share screen and go on to our slides for Mary on why pollinators matter. So Mary, I will invite you to unmute yourself, and you can get started. For anyone, just to say, interested in finding out more about Green Foundation Ireland, just visit the website greenfoundationireland.ie. Thanks, Mary.
Thank you, Claire, very much. I would first of all like to say how lovely it is to see that beautiful sunflower as your logo. Obviously, it has two meanings for us, sadly, these days. It's a wonderful plant for pollination, of course, but it also is the national flower of Ukraine. And I'm very proud to say I was involved in a plant sale on Sunday where we raised a very large amount of money, I think something like 24,000 for Ukraine. I think it was a great effort of the gardeners of my area of Ireland, and I'm very, very proud of it. So that's my just my start, if you don't mind. But really what I need to talk about is something which has been on my mind, well, now over 20 years, because it was a slogan at the beginning of this century. As the century began, we had a slogan. It said, think global, act local. And if ever there was something which is, I think, a really good slogan for getting change started and getting people to notice things, it will do for the whole of the century, probably. And it will certainly do for helping pollinators, because your local actions, the local things you do, will immediately show promise of better conditions. The reason for this is extremely simple. There is an extremely intimate, vital relationship between pollinators and the plants they pollinate. And we know that actually almost everything on Earth eats plants in one form or another. Even if you are a complete carnivore and you never eat your peas or cabbage, you are still eating an animal that has fed on vegetables. So take it from me that without pollinators, without allowing the plants actually to increase, to crop, in fact, we would be in a really bad state. One of the books I've had the very great privilege, really, of reviewing recently is a new book on pollination as such by an English writer called Timothy Walker. And he has, I think, a very interesting and helpful angle on the whole thing, because he sees it as a botanist, largely, he sees it largely from the point of view of the plants. And so I'd like to start there with the problem that plants have. Now, Timothy Walker isn't the first person to notice that plants have a serious problem because they are rooted in one spot. Being rooted in one spot rather confines your gene pool to what's immediately around you. But if you can transport your genes somewhere else to find somebody else of the same species, but not so closely related, then your gene pool can be very, very well diversified. And this is extremely important. And this is the basis of the whole pollination network that we see all around us, all the time working for us. It, in fact, this issue of pollination has, I can put it into a nutshell for you. E.O. Wilson, I'm sure you know his wonderful book called The Diversity of Life. This is a quotation from that, a very brief one. He says, quite simply, biodiversity is our most valuable but least appreciated resource. And I offer you to think about that. It is very underappreciated. Think how, for example, we'd like to see a nice lawn with no daisies or dandelions or plantains popping up through it. Haven't we been doing that for years and years? Actually, that is, to a pollinator, a desert. Grass does have pollen, but it's not much use to pollinators. Most of the pollinators will go for non-grass pollens. One or two do eat them. But I'm just going back to my problem of the plant being fixed in the one place, but needing to spread its pollen. And you've already got the first point, which is that there are two natural means of dispersing pollen, which don't require active pollination by animals. One, obviously, is wind. Wind pollination carries the pollen grains from one plant to another. And we use this all the time for all our rice, wheat, barley, all those crops which are grains. And it is very, very important. But wind pollination, in my view, is really rather expensive on the plants. An awful lot of pollen does blow around, and only, after all, a small and limited amount can actually pollinate other plants. My best example of this is conifers. Conifers are what we call Gymnosperm plants. Gymnosperm in Greek, I think, means naked sperm. And you'll know, actually, you've probably been seeing it in the woods at this time of year, you'll know that sheets of pollen blow in the wind when the conifers are beginning to flower. And the pollen often is just lost on puddles and beaten down by rain and so on and so forth. So I'm asking you just to think, really, isn't that a very expensive way for pollination to take place from the point of view of the plant? Yes, if you produce a very large amount of pollen, that will work. The male principle will be transported to the female and you will get sexual diversity, which is what we want. But it's expensive. In fact, even conifers have noticed this. And there is a wonderful thing. If you look at the very top of where the cone is, the cone will form, and you can see the little conifer flower, you may notice that there are sort of two little tiny protuberant ears, almost they look like, at the top. And those little protuberances, when the wind blows, they form a vortex which tends to draw in pollen to the female flower of the plant. So plants are very ingenious, but all the same, they cannot move. And this is why pollination of all sorts carried out by animals is so extremely important to the diversity of nature. We know that gymnosperms evolved in that way, with what are called naked sperm, that is, that the pollen flows out onto the wind. They don't try to protect it. Whereas there are all the flowering plants, which we call angiosperms. And I believe that means, I haven't any Greek, but I believe that means that they keep their seeds in a pot, angiosperms. This is for protection. The seed, the fertilized ovule, which forms the seed, actually has a protection. It's a seed covering, and that's the process of pollination, obviously, taking place. Now, I want to stay with pollination and not move on to seeding all around, because pollinators have no concern. Well, I say they have no concern with seeding all around, but of course, animals moving among plants which have seeds already on them are highly likely to carry seeds around. And there are, in fact, other pollinators which nibble away on the seeding the fruits which contain the seeds. Think of your rowan in the autumn with the beautiful berries and the birds pecking away at the berries and transporting those seeds around the country in their gut, of course. So pollination and seed dispersal very closely linked, but animals are the main vectors, as we would say, the main ways in which plant diversity is maintained in the environment. This is terribly important. I can't emphasize it to you enough. Just this last year, the Royal Botanic Gardens at Kew have produced a report. It's quite a stunning report. It's called The State of the World's Plants and Fungi. And it was actually produced in 2020, but I've only really just fully read it. They reckon that 2 in 5 of the known species of plants all over the world are actually threatened with extinction. That is 2/5. I don't know quite how they arrive at this, and I know that plants are being identified for the first time all the time. We have various wonderful discoveries in jungles and forests and so on, showing that there are still plants to be discovered. But it is extremely important that we recognize that many plants may be on the verge of extinction. And the reason that this is happening is the loss of habitat, the change of the environment that is largely precipitated by farming, in fact. So that farm agricultural lands tend to be poor in biodiversity, whereas obviously land which is just left to do what it does tends to be much, much richer in biodiversity. I'm going to be very clear that this is insects and small animals as well, and birds, I'm not just talking about plant diversity. The nature, this intimate nature of the pollinators with the pollen-bearing plants means that they find niches with each other, they coexist. Some bees, for example, really pollinate not very many different plants. I'll give you a little example. I'm not going to go on about bees, I promise, but one little example is the orchid bees that we find in the Sonoma Desert over in the United States. These orchid bees are quite astounding. They're little tiny bright blue bees, and they collect. They don't really care about the pollen very much, but what they do care about is their mating procedure, and they collect molecules of the scents of the orchids, which they transport from flower to flower, in the process allowing the orchids to do two things. One is obviously to deposit a pollinia of pollen on the head of the bee. And then when the little male bee goes on to the next plant, where does he go? He's going burrowing down for the lovely scent that he wishes to attract the female with. But as he goes down, doesn't the pollinia leave his head and head into the right place in the orchid? These astonishingly, well, it's a word that many people nowadays do use, intelligence. The astonishing intelligence of plants is demonstrated in so many ways. But there's yet another little bit to this story. That little bee may be collecting maybe 7 or 8 different scents and can actually carry them on different places on his tiny body. Now we're talking at molecular level because these are molecules of scent. I'm not a scientist. I don't understand what this all really means in terms of what you would see down a microscope. But I do know that those orchid bees have co-evolved in this mutual arrangement with the orchids in order to be able to mate. They attract the female little sweat bees, the little orchid bees. They attract the female with these scents. This is such an intimate and intricate relationship that I would like just for you, if you can, to hold that in your heads while I sort of deviate off onto all sorts of other ways in which plants can get pollinated. The result of flowers beginning, which is about, we think somewhere between 150 million and 130 million years ago. You see, flowers don't last very well in the fossil record, unlike pollen, which is excellent in the fossil record. So we have actually, at the moment, as far as I can work it out, there is a kind of anomaly going on, because we have much older pollen, which looks as if it comes from flowers, but we can't be sure. That may go back to 200 million years ago. And that was some cores that were drilled in Switzerland quite recently, about 2015. So those, we can't place a flower for them because we have no fossil record of those. But we know that that kind of pollen is likely to have come from an angiosperm, a flower. Whereas on the other hand, pollen itself, as I say, is used in the fossil record when we find And we do occasionally have the good luck to find maybe an insect trapped in amber. Claire, can I get you to show my first picture? Now this, I think, exquisite jewel is actually a tumbling flower beetle. Now it's not a bee of any sort. It's not a pollinator in the sense that it doesn't carry pollen. Tumbling flower beetles, this is a Burmese one, obviously, as you can see from the name, which I will not attempt to pronounce, but Burmetina obviously means from Burma. And in fact, I know where it came from. It came from a part of northern Burma called Kachin State. Very, very rich and still somewhat unadulterated jungle up there. Anyway, this beautiful piece of amber containing the tumbling flower beetle, which is easily recognizable. It actually is very like the tumbling flower beetles we still find in Thailand, Cambodia, in Burma. And this we can date. This we can date to about 120 million years ago. Now, what this tumbling flower beetle is among is quite a bit of pollen. I'm sure you can see it quite clearly in the amber. And that pollen, which obviously comes from angiosperm, from flowers, that pollen is not really of interest to the tumbling flower beetle, except that the tumbling flower beetle has been in the flower and has munched up quite a lot of pollen. We call tumbling flower beetles, we call them messy feeders, right? They make an awful mess of the pollen when they feed on it, which is how such a large amount has ended up in this piece of amber. So this is one indication that pollination has never been a simple matter of just one form of transport of the pollen from one flower to another, but it is actually very complex and depends on the habitat where the flowers and the creatures are, that they actually interact, and they find what I always call niches, but it's too small a word. They find ways of cooperating, systems, as it were, within their habitat. And that to me is the essence of good biodiversity, that there is lots of room for lots of species to manage to coexist. It's sometimes called mutualism. I'm not sure whether a lot of scientists like that phrase. Some people call it coevolution, and people, again, object to that phrase. But you can see the point. It's a very, very simple one. These, for time immemorial, have been working together. So that what we look at now is an incredibly intricate, complex, subtle system, which we call our world, and which I have to say never ceases to amaze me. I can't tell you how much. There's just one more little tiny bit that I wanted to add in. And this is really taking a little sidetrack, if I may. I hope you don't mind. You see, pollen is really quite an interesting sort of a thing. And our flowers and our grains have pollen. But there is a sort of other kind of transport of sexual, male, obviously, material between plants, which we find in ferns and mosses. And these I don't understand yet, but they obviously do at some point relate quite closely back to the pollen that we see in angiosperms, because there is something called sporopollenin. Now, sporopollenin is what makes the spores in ferns sticky, so that when they fall off, you know, ferns don't tend to be hugely tall, but they fall off into the environment. They can stick where they need to. And that's true of a lot of pollen. As a beekeeper, you learn to sort of look at what pollen might be. And there is this wonderful material called pollen kit, which actually enables pollen grains to be a little bit sticky, so that when they reach the stigma of the flower that they're going to pollinate, they actually can help themselves by sticking just a little bit. So it's not all down to the transport. It's actually the structures of pollens themselves are part of this mutual agreement to get on with each other in this intimate fashion. I was listening to a woman on the radio some time ago, maybe a few months ago, and I was so charmed with what she said. She was an American moss expert. Now, I have no interest in moss, but she was most interesting. And at the end of the talk, the interviewer asked her, so are we all doomed? Pollution is so serious to moss. We realize we may be losing a lot of species. Are we all doomed? And she replied very simply. She said, well, I believe in photosynthesis. And that's, I suppose, the point that I would like to make. I also believe in photosynthesis. So again, that plant ability, that extraordinary ability to use the sun's light to produce sugars, carbohydrates, all the things that it actually needs for its own nutrition through this process of photosynthesis, that is a miracle in itself. And I've never understood the chemistry of it, but I never cease to marvel at it. Now, I would like to show you my pictures quite soon, but I would like also to give you from my Timothy Walker book on pollinators, I would like to give you a wonderful, what I think of as a wonderful job description, he calls it, of what a pollinator needs to be. So first of all, it goes. First of all, a pollinator must provide safe and timely transport, right? So it's possible that the timeliness may not be there with wind or water, if you think about it. Maybe the wind doesn't blow very much. And the water pollinating, carrying the pollen around, which also happens underwater, because you may not know, but underwater plants are also pollinated. They don't all do what water lilies do. Water lilies, of course, pop their flowers up and open up, and their stamens are there with the pollen for a pollinator to visit. But lots of plants actually pollinate underwater with the pollen washing around, which is very similar to the wind pollination. So safe and timely, that's not entirely reliable from wind, probably pretty reliable from water. But how about this one? This pollinator should return each year or send its offspring in order to pollinate the plant on its annual cycle, or the species, I should say, of plant on its annual cycle. So that, I would say, is very unlikely for wind and water. That really produces a need for an actual creature to be doing some pollination. And the last bit here in Timothy Walker's job description is it should share a similar habitat with the plants it's going to pollinate. And that's a very clear, necessary thing. Just apropos again, if we don't mind me taking a little side, we're a little bit worried about bumblebees. Bumblebees are doing quite well in a number of ways, and we're trying to look after them. But one of the things that is a bit troubling is that they don't seem to be coping entirely well with global warming. Lots of bees are coping quite well with it, but the bumblebees, for some reason that we don't yet understand, don't seem to have been able to shift themselves further north in the way that we would have expected. So this business of to share the habitat and not to be too specific about which plants you use, this is beginning to see in these cycles that there are possibilities of extinction even without human intervention. I know that there have been other periods of warming and cooling on the planet, and we have lost many species, many more than in fact exist now. However, there are other aspects to being a pollinator, which Timothy Walker talks about. And these are specifically for the animals that do with the pollination. One, they must be reliable. Now, you can't be very reliable if there's only one or two of you in a place. So the second part of this is sufficiently numerous. So you can see that we're beginning to look at various kinds of animal societies for doing pollination. Obviously, this brings bees in immediately, because bees, a lot of bees are social, but even solitary bees tend to live in sort of convivial groups, I think you'd call them. So although they are not social bees. They are solitary bees. That is one female for each nest. And it's only her eggs that go into that nest, unless a cuckoo comes along, a cuckoo bee, and steals it. But one way and another, they tend to lay in groups. They like to make their, like Osmia bicornis, for instance, you'll find probably popping out of your lawn at some stage round about now. You will find maybe, 3 feet or 6 feet of the lawn covered in these lovely little solitary bees. You wouldn't call them solitary when you see 100 or so emerging like this, but each one has had a separate nest under your lawn and you didn't know it. So those are sufficiently numerous as well. And the pollinators must also maintain sufficient physical fitness to be able to perform. And this, I suppose, is quite a problem. It's one of those things that we imagine for butterflies. I often look at butterflies and think to myself, how does something as delicate as you manage with this buffeting wind and these heavy raindrops? And of course, I discovered an answer. In fact, I was delighted to discover an answer only a little while ago when I saw a butterfly so cleverly hanging underneath a dandelion leaf, keeping herself dry, because of course the dust on her wings would be disturbed if she was wet. So another thing is that the pollinator needs to be of a suitable size. So some tiny pollinators and some much, much larger are necessary to keep this biodiversity turning and to keep it continuing and developing. Evolving is the word I really need. So finally, Timothy Walker thinks that there shouldn't be any carnivorous pollinators, but I think he's wrong. I do indeed, because I include on the list of pollinators, I include humans. And quite a few of us are carnivores, but I can give you a better example from nature of a pollen-eating wasp. There are very few pollen-eating wasps. It's not a common form of wasp, but they obviously are important pollinators, but they only feed the pollen to the larvae, and they do actually catch other insects. So wasps have a sort of, they have a flexibility about them. They are remarkable creatures, and please, 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 don't worry about wasps in your garden until much later in the year. They are doing a great job. They are catching green fly, black fly, white fly, you name it. They will gobble them up. They gobble up the eggs, they gobble up the larvae, and they even eat the flies themselves. So they are doing a great job for you on your prize plants, I promise. So in fact, you can see that all sorts of creatures would fit the bill as being very good pollinators in different circumstances. And if I may, Claire, I'd like to show my pictures now, because I've got an awful lot of different pictures to show you of different pollinators. So I'm going to start here. No, I think I've got one before that, haven't I? Is that number one? Yes, it is. Okay, well, I'll start with my honey possum if that's it. I've got my list out of order. Oh no, there we are. Right. I may have told you about this before. This is a story which actually moved me so much that I had to find out more about pollination. And it's in a book which I love still, published in the 1990s by Steve Berkman. It's called The Forgotten Pollinators. It may still be available on Amazon. It's a wonderful read. In it, he talks about that little gorgeous creature, Australian, obviously a possum, which is there, as you can see, you can even see her tongue. I presume it's a her, I don't know why, feeding on the nectar, which the Banksia has in such rich quantities. Banksia is a very nectar-rich plant. And there was, according to Steve Buckman in that book, there was a very rare Banksia in Western Australia, in the semi-arid really. They don't really need a lot of water. It was called Good's Banksia. It was named after the botanist who discovered it. And this existed in sort of largish patches, but it was quite a sparse plant, always quite rare. So, I mean, Australia needed to develop, and it put a nice big road from Adelaide all the way over, all the way to Perth, etc., etc. And what happened with that was that the Banksia plants were left in such small numbers, they were not really any longer attractive to their main pollinator, the little honey possum, who could go to any kind of Banksia and have a meal, thank you very much. And so the honey possums quite simply stopped visiting the Banksias, the goods Banksias. And the result was that within quite a short time, goods Banksia became extinct. Now that, the population becoming, in that sense, unviable because the population itself is too small and it can't regenerate itself, that is known as the Allais effect. And that was exactly what happened to goods Banksia. It's a very important concept. It's particularly important when you look at the agricultural landscape and you realize that there may be acres of monoculture with no biodiversity worth speaking of left. What happens there to wild pollinators, the hoverflies, the bumblebees, the solitary bees, the butterflies, the wild pollinators that we all love to see, is that once, let's say it's oilseed rape like you're seeing around the country at the moment, that once that oilseed rape has finished flowering, there is nothing for those pollinators to eat. If we make enormous fields like that and we take out the hedgerows, what happens is that our biodiversity in the little patches that are left falls away and becomes extinguished through this thing called the Allais effect, where a population cannot keep itself going. So I'll just pop on to the next slide. Thank you, Claire. Now, this is a very strange creature. As you can see, this is the Drakensberg crag lizard, and the photograph was taken in 2019. And this lizard is kindly pollinating what we call an earth plant. You can see why. There it is in the Drax, just in a crag of the rock, and it just puts the flowers at ground level. You may have a flower in your house like this, because this is exactly what aspidistras do as well. But it's very unlikely that a flying pollinator will ever find these plants because they're actually hidden under the leaves. As far as I know, they're not scented. And certainly I know the aspidistra isn't scented because mine has flowered and it didn't have a smell. So one way or another, other pollinators have taken up, as it were, the work. And here we have this lovely lizard with his tongue out as usual, supping away on the nectar. This is much more important in pollination than you may realize. You think of the pollen, you think of the bees collecting pollen, and you know that the bees use the pollen to nourish their larvae. But it's actually, most of the pollinators I'll be showing you will in fact have been largely attracted not by pollen, but by nectar. So like the tumbling flower beetle that makes a terrible mess and there manages to pollinate, the little possum and this crag lizard, they are kind of messy eaters and they carry the pollen around without caring about it because they've got the nectar. Can I go for my next one? Thank you. Now this is a lemur. This is known as the world's largest pollinator, as I kindly put on the top. And this is a Madagascan, a rare creature and a beautiful, as you can see, a most beautiful lemur. Now these are quite remarkable. One of the wonderful palm trees, rare palm trees indeed in the world, is known as the traveler's palm. And this is actually entirely dependent on these lemurs for pollination. So the lemurs, I don't know whatever it was, whatever complexity enabled this to evolve, but the lemurs will actually carry pollen-bearing flowers from one palm to another, right? They are astonishing. Of course, they're going for the fruits, and they're also going, he forces the flowers open to drink the nectar, and his pollen the pollen covers his nose, may keep the flower and take it on to the next, but he's poking his nose in so eagerly that those flowers gather the pollen from the last flower, and so on and so forth. And that's, so as far as I understand it, more or less the sole way that those travelers' palms actually do get pollinated. Now, that's a very risky policy, very risky, not to be recommended. And indeed, as we know, Madagascar and all its wonderful, extraordinary, rare forms of life which have evolved on that island in mutual dependency and mutual benefits, that is always under threat. If you want to understand a bit more than that, then may I recommend E.O. Wilson again. He talks wonderfully about how speciation happens on islands. It's something he's studied very much, and it is a fascinating story. And it does depend very much on the niches on the particular island, because transport over water is much more difficult, unless, of course, you're a bird. In which case, if I can go to my next, then you probably won't have the same problem with your pollinating the birds, if the birds will do it. Now, I have to confess, I am completely self-indulgent, and Claire, I hope you will understand this, in showing you these three pictures of birds which were familiar in the garden where I was brought up in my teens, which was in the Dandenong Hills outside Melbourne. Here is one of our favorite birds, a Wattlebird. It's not a tremendously good picture, but she's on a grevillea, which has again these strange loopy nectar-bearing flowers, and they would simply feed until they were full on the nectars, and then off they'd go. We had numerous ones. They are noisy birds. They like to make their presence felt. And the next one, much sweeter little thing, which we had a lot of. Thank you, Claire. The little silver eye. Again, you can see this tiny bird is actually performing the role of a pollinator, even though she's really only looking for nectar. I think she's on some kind of eucalyptus there, but I'm not sure. No, sorry, of course it's not. It's a small bottle brush. So it's probably a small callistemon. And the last one of these three birds of the area which I was living in is the rainbow lorikeet. These are the noisiest birds you can imagine, apart from the other lorikeets and the cockatoos. They scream and screech, and you cannot miss them. Look at the colouring, and look how the colouring is perfectly appropriate to the colours of that flower. Isn't that glorious? And there again, all that lorikeet wants is the nectar. So this is immediate nourishment for the pollinator. We call them pollinators because they're doing the job, but they have actually no interest whatsoever in pollen. So I'd better get on to something which is also eating nectar, but is a bit closer to home. And this is my own garden. Thank you, Claire. I'll go on to that. And this is last year, in fact, but this is a lovely plant. And this was a very early picture. The Edgeworthia flowers very early in the year, which is why I have it in the garden. And as you can see, it hasn't fully opened. Some of the flowers are still waiting to open. So this plant was in flower in February when I took this picture of a small tortoise shell on my garden in Bray. I would like to emphasize now, again, as I think I did in my other talk, how important it is for our pollinators to have food if they do come out. We're in this period of global warming, and we know that it's actually the temperature that tends to bring out the hibernating insects. This will happen for bumblebees, and it happens for butterflies and ladybirds, lots of creatures that we value very greatly. And if they come out and find nothing to eat, then quite simply they can just die of starvation right there and then with the cold. So one way and another, if I can get you to plant things, especially shrubs, which will have lots of flowers in the depth of the winter, they'll not only give you pleasure, but you'll also have the pleasure of seeing the pollinators fed when they have foolishly come out when they shouldn't. I'll take the next one, please. Thank you. Now, these are This is again, you see two hoverflies there? These are excellent pollinators. Hoverflies have a great appetite for pollen, and a little bit like the tumbling flower beetles, though not quite as messy, I ought to say. They do chomp away on the pollen, and in moving from these tiny, the little tiny heads of flowers on the ceanothus, moving from one to the other, they accidentally, of course, pass the pollen along. And you'll see the ceanothus is absolutely brilliantly adapted for that, because you can see how the anthers, those yellow bits, stick up with the nectar, apparently offering it as a meal to the hoverflies, but actually, of course, saying, just carry some pollen along for me. Be a reliable transport for my pollen. I can see I'm running out of time a little bit, so I'll continue on if I may. Thank you. Now, this picture I am offering to you as a challenge. Here it is. I actually, although I named it 4 pollinators on ragwort, when I looked at it on my computer just a little while ago, I actually found 6. I don't know how many you can find, but there is a bumblebee at the top. It's Bombus lucorum. Can you see her feeding there with her nice bright white tail? You have a bee fly down at the front. This is a bee imitator, but a good hoverfly. You'll see ordinary flies, at least a couple of them, and there's another hoverfly right down at the bottom. So I actually managed to count 6 on that one head of ragwort. Now, it is true we all hate ragwort. We have been trained over many years to see it as a pernicious weed. But I did learn something by being observant, a little bit observant, which was about 5 or 6 years ago, there was a field at the bottom of Bray Head which went completely yellow with ragwort. And I was thinking of, oh gosh, surely somebody should do something about that in that old-fashioned gardening type way. Surely they should all be stopped, right? But within 2 years, there wasn't a scrap of ragwort to be seen in that field. This is because this plant, Senecio jacobiae, is actually biennial, and it tends to die out pretty quickly, actually. I mean, it'll go somewhere else. The pollen and the seeds will transport themselves around, but it's not anything like that terrible, pernicious invader that perhaps we were taught to think. So thank you. That's my little moralism about ragwort. And the next one? Yes. Now, this is back into the garden here. This is a real favorite of mine. This is a nice little solitary bee called Nomada. I think it's Nomada marshmallow, but there are so many different little solitary bees that we have in Ireland. I'm never confident to try and identify them properly. And you'll see she's a proper bee. I'm afraid in this particular picture, you can't see very well. She has a wonderful way of carrying the pollen. She has a hairy underbody. Her whole stomach, her whole tummy, I should say her abdomen, I'm sorry, actually just covers itself in pollen. So as she moves along, gathering up pollen in these beautiful branched hairs on her abdomen, she is also carrying the pollen from plant to plant. That's just my ordinary inula. You probably all know it. It's sometimes known as elecampane, a plant which I always find very attractive, and I like ragged looking things. And then the next one, please. I'm off into things that I am going to be recommending. So because I am wanting there to be biodiversity, I want there to be things like thistles in the fields. I know it's a bit of a nuisance. And if you can just leave some patches of thistles, you'll see more in the way of bees coming along than you can imagine. That's Bombus lapidarius. It's probably a worker. And there she is, sticking her nose in to get the nectar and the pollen. Well, actually, she looks as if she's nectaring. I can't see any pollen on her thighs, so I think she's just nectaring. They do tend to do one rather than the other. Honeybees, of course, are very strict about it. They do one or the other. But sometimes bumblebees do both, and they really need the wildflowers. If you can just keep some wildflowers in your garden, any patches that you see, please don't think of trying to get away with just chopping it all out. Let them seed, let the seeds fly far and wide, and let's keep the biodiversity. And the next one, please. Yes. Now this is back to the garden. Now you remember one of the things that Timothy Walker said was that the pollinator needs to be of a suitable size for what she's going to pollinate. And I have to say, this plant puzzled me for a while until I actually caught the pollinator at it. This is a lovely Channel Islands plant actually called Echromacarbus scarba. It means scrambling. And boy, does she scramble. And she has these wonderful, bright, vivid flowers. And the bee that loves these best is actually Bombus pascorum. Can you see Bombus pascorum just coming down at the bottom? She's the ginger bee. Now, to my amazement, she can get right into that tube, right? And back out again. And she does. This brings me around to the idea of some of the other birds that you should have seen, but I haven't had enough room and time. But you know, this is very like hummingbirds. Lots of tubular flowers are really co-evolved with hummingbirds. We don't have them in this country. And the Wattlebird, I don't know if you remember, had a lovely curved bill in order to reach into the areas where the nectar would be, but thereby passing the pollen on the stamens and getting messy. That good messiness is what that's all about. So I don't know whether my little Bombus pascorum in the garden here was actually going for nectar or for pollen, but she was going right into those long tubes. And a very brave little creature, I think she must be. The next one, please. I'm onto my own bees now. Here I have, this was taken in a local quarry, not actually just in the garden. It's just marjoram, the wild form of oregano, as you probably know. And you can see again that the honeybee, this is Apis mellifera, and it's a nice dark one, so I would guarantee Apis mellifera, our native Irish bee, as we call it, our black Irish bee, is having a whale of a time. And you can see that lovely head opening flower by flower. So that will go on over a slightly extended period. It's not just a flower and gone. Wonderful, lots of the herbs, lots of the umbelliferae, lots of these plants with numerous flowers, open in sequence, like the Edgeworthia, like this oreganum. They open in sequence, and that provides a longer period of feeding for the pollinators that attend to them. And the next one is the same. It's my old Edgeworthia, there being visited by one of my bees in the garden. The same story. I know that one taken, in fact, it was taken at the end of January, that one, it was so early. That one really was very useful to that bee. I don't know what she thought she was doing out in January. I would have much preferred her to stay in the hive like a sensible bee, but out she came, and there she is getting, can you see her tongue? Can you just see a long little red tongue going down into the flower? That means that she's gathering nectar, and that will give her the energy to return to the hive, even in the cold. So there we are. And now I've got two quite different aspects to bring to your attention. The first is about, well, I want to show you something. First of all, can I have the Great Green Wall, please? This extraordinary picture is part of something called the Great Green Wall of Africa. And I really hold a torch for this project. This project, which involves 21 African countries, is to force back the desertification, which has taken up such a lot of the southern part of the Sahara, which we call the Sahel, has now been involved in this major project, UN-supported project of regenerating and forming what they now call, and what's been called, I think totally accurately, the Great Green Wall of Africa. Now this reflects the work done by another Australian, a man called Tony Rinaldi. I think that's how he pronounces it. He's dead, oh, I suppose maybe 15 years now. But he was working in Nigeria and back in the 1950s, and he reckoned on something which was remarkable. He saw that although desertification was taking place because of overgrazing, because of people needing the land to keep their cattle largely, or for crops indeed, and the desert was forcing them further and further south because of the loss of habitat, he saw that just the mere stumps that were left that didn't seem to be any good, and which very often the agriculturalists would just tear out, root out. He saw that they regenerated if you could leave them. And he came up with this idea of regenerative farming, which is the basis of the Great Green Wall of Africa. The Great Green Wall of Africa is based on this principle. It's a very careful principle whereby particularly women actually are being employed and trained in how to get those remnants to come back. Now, they are the original plants of the place. They are the original plants of the habitat. And with them comes again a regeneration of the animals that live there too. The insects, the birds, and of course, the beautiful, beautiful mammals. I really want to say to you, the Great Green Wall of Africa, I'm nearly out of time, is one of those examples of the very best principles of biodiversity at work for people. And I am a great, great believer in it. If you haven't looked it up on Wikipedia, please do. So finally, my last picture, and you will forgive me, this is our landscape. This is a hedgerow local to me up at Rathmichael. This hedgerow, which I love dearly and I watch every year, is a superb illustration of exactly what Charles Darwin was talking about when he thought about evolution and he realized that it's all this wonderful complexity. Can I read you just a little bit of Charles Darwin to finish? What he said was, "It is interesting to contemplate a tangled bank clothed with many plants of many kinds, with birds singing on the bushes, with various insects flitting about, and with worms crawling through the damp earth, and to reflect that these elaborately constructed forms, so different from each other and dependent upon each other in so complex a manner, have all been produced by the laws acting around us." So that's what I would like to finish with. Thank you.
Thank you so much, Mary. I think we could probably all listen to you all night, and I can't help but feel both fascinated and really buoyed with hope from your stories and wonderful sidetracks and incredible variety of pollinators, from lemurs to orchid bees to everything else in between. Love the definition of a pollinator, and as you were reading it, reliability, numerous, physical fitness, size. I was wondering if humans could ever be pollinators, but you mentioned they could.
Well, we do it all the time because we go and plant seeds. Essentially, we're part of a network. If we could only get back into harmony with doing that, you know, I do think that's the important bit. I don't think we're harmful as such. Please God. Yeah.
Another message of hope. There were some questions about some of the names of slides. Do feel free, please, to add to the chat or put up your hand if you have any questions at all. And I'm sure there are lots of questions. There was a question about Ian E.O. Wilson, US scientist. That was answered, I think. The first shrub with the butterfly
is Edgeworthia chrysantha. And it's Edgeworth, they were named after the Edgeworth family, actually, the Irish family. And sometimes we count it as being an Irish heritage plant with the Irish Garden Plant Society. Edgeworthia. It's a Chinese plant. They use it for making paper. It's a little bit difficult. Some people find it a little bit difficult to grow. It doesn't like to be too windy, but it has those lovely scented, and that's why I got it. I smelt it in Kew one day and I said, I have to have it. Right? So there I was being a pollinator. Edgeworthia chrysantha. Chrysantha meaning golden, yes.
Fantastic. I have one question. I can't see any others at the moment, but do please feel free to add them onto the chat. As you talked about Edgeworthia, are there other early flowering plants that are Irish or UK origin that would be, I suppose, more native that would flower across winter or even early.
Not great, not great. I mean, really, dandelions are wonderful, right? Oh, don't get me started on dandelions. I've been finding out about dandelions. Did you know that dandelions can reproduce both sexually and asexually? And they are called apimictic, right? When they don't produce sexually. So when you look at your patch of dandelions, you're looking at an amazing population with all sorts of special, there's a diversity among their genes, which enables there to be ones which are producing sexually viable seed and ones which are also producing seeds asexually. Now those seeds are viable as well. So when you see everywhere covered in dandelions, you will understand they've cracked, I think they've cracked the universe, really. So it's not great, but a lot of garden plants, because gardeners like flowers, are excellent. And let me, again, encourage you to plant shrubs and early flowering trees. Anything that you like the smell of is sure to be attractive to pollinators. As you perhaps remember, I'm sure I was preaching to you about my very favorite plant, which is a Daphne bolua, which comes from the Himalayas. It's as tough as anything I do find. It is very easy. It does sucker a little bit, but it has a scent so strong that the entire garden is filled with it from the early part of January all the way through to the end of whatever. Let's see, end of February, certainly. And it's always full of pollinators if they're out. So I can hear a phone.
I thought it was an alarm. There's one question here about foxes being a very common sight, even in urban areas. Do they do anything for pollination?
Well, I'd never thought of that. I think if you're thinking of them as fruit eaters, like the fruit bats, you could be onto something. And it's certainly true that foxes like sweet things because they like the sweet things in your dustbin. I suppose we could say that the sweetness in nature, which is brought about from photosynthesis producing sugars and carbohydrates, that might be attractive to anything. So if maybe your apple cores are not fully digested by your actual fox, who then has to go and dispose of them somewhere else, you might find a very interesting sort of apple growing somewhere. Or in my case, I'm not a very good compost maker, and I do tend to throw peach stones into the compost and they never rot down. And last year I found a peach tree growing entirely in the wrong place, and I'm going to have to get rid of it, but I had to wait for it to flower to find out what it was. So it has obligingly put out a flower, so I know it's a peach. And the second thing is, it's got peach leaf curl, right?
Trash.
Yes.
But a good effort nonetheless. Wonderful. I was just going to share a link here to, I think I found the right report. You mentioned the State of World's Plants and Fungi by Kew Gardens, which is a beautifully produced report. You mentioned another author, Timothy Walker.
Yes. His book is called Pollination. It's quite new. I've forgotten exactly.
And I also noted down the Forgotten Pollinators. Is that Stephen Buchman?
Buchman, Buchman.
They're the three. I'll pop them into.
And that would have been about 1992. That was produced.
Wonderful.
That is a wonderful read.
Fantastic. Well, thank you so much, Mary, for an absolutely fabulous talk this evening. Always so engaging and interesting. It's very much appreciated. We will be putting this recording up on the Green Foundation Ireland website afterwards. And if anyone, oh, sorry, there's a question, is there?
Sorry, just one question.
Yes.
I was going to ask Mary, I have the belief that it's better to let things grow rather than plant them, that planting them is the second best to letting things grow. I don't know whether she would agree or not with that.
Well, I'm going to be, I am a gardener after all. I love putting garden plants in and I love to watch them grow. And I'm fascinated by plants. So any kind of a plant is interesting to me. I don't root out weeds. I tend to let them go and then sort of think, well, I'll try and grow a shrub over that to keep it a bit quieter. So my answer to you is really a contradiction. I do understand why you say that. And I have often asked people to do a particular exercise in order to prove it. That is, if you mow your grass, and most of us do mow our grass, maybe not very much, but we do. If you would just leave a square meter, which you never mow, and look at it next year and see what is growing there. I had a lovely woman once in one of the groups I was talking to, who came back to me the following year. And she said, I did that. And do you know, I had 36 different types of plant and I had to look them up, right? So I have to say, is your name Thomas?
Yes.
Yes, I think you're right in principle, but I'm a gardener and I do love to have the plants that I like. So I would like to keep able to garden. So will you forgive me?
My blessing.
Thank you.
Great. Are there any other questions if anyone wants to unmute themselves? No. Thank you for that. Okay, well, we'll wrap up this evening. Thanks again, Mary. If anyone is interested, Green Foundation Ireland is doing another talk this Biodiversity Week on Thursday evening about beluga whales, which is also going to be a very interesting talk. So we do invite you to register, and all the details are on the website for that as well. Otherwise, thank you very much and have a very nice evening.